going to talk about the structure of carbon and functional groups. This is just a very simpler version of what I'm talking about. If you want a more in-depth, I have a video for this on AP Biology, and you can find out a little bit more about it there. So when we talk about functional groups, we need to talk about carbon. Carbon has a lot of very specific characteristics that allow it to do a lot of different things. So when we talk about organic chemistry is the study of carbon, and carbon likes to covalently bond with itself. It can make long chains, it can make rings, it can do all of these really neat different things that other molecules can't. We have organic compounds. These are going to be compounds that have a lot of carbon and hydrogen in them. Sometimes you'll hear about hydrocarbons, and those are molecules that have carbons and hydrogens. So one specific characteristic for carbon is carbon has 4 valence electrons. So when I look here at my group, carbon is in group 14. Remember, when we do valence electrons, if I remove that 1, I have 4. That everybody in this group has 4 valence electrons. So a characteristic of 4 valence electrons is how they react to the octet rule. So remember, octet rule is the rule of 8. They want a full shell of 8 or they want an empty shell. Carbon has 4 valence electrons. So is it easier for carbon to bring in 4 electrons or to get rid of 4 electrons? So carbon can do both. Carbon can bring in 4, and now I have a full shell of 8. I have fulfilled my octet rule. Or carbon can get rid of them. It's going to use the same amount of energy either way, to bring in 4 or to get rid of 4. So this characteristic of carbon and these other elements similar in this group 4 have this capability of being plus or minus 4 when we're talking about valence electrons. Carbon bonds, they can form a bunch of different types. They can do a single carbon, where I'm going to have a single bond, which means only 1 electron is getting passed back and forth. So when we see these bonds, these are all just showing 1 electron getting passed back and forth. When I see them like this with these 2 lines, this is telling me I have 2 electrons being passed back and forth. So remember, carbon can have needs 4 valence electrons. So carbon can borrow, this carbon can borrow 2 from this carbon. It's going to borrow 1 from hydrogen and 1 from this hydrogen. So this carbon will bring in 4 electrons to give it its octet rule. This one here will bring in 4, 2 from this carbon, 1 from that hydrogen, 1 from that hydrogen, to give me this group of 4 that will be added to carbon's 4 to give me my group of 8. Here I have triple bond, so that means 3 electrons are getting passed back and forth, so 3 electrons will get passed back and forth between those 2 carbons. This carbon will borrow 3 from this one, and then 1 from hydrogen to give me my 4. This carbon will borrow 3 from this carbon, 1 from hydrogen to give me my 4. So carbon can make 1 bond, 2 bond, or 3 bonds. Carbon can use its ability to make really long chains. So here I have this molecule, I have carbon, and you can see carbon likes to create what's called a backbone or a skeleton, and it's going to create these long carbon chains. Here I have another carbon chain, here I have another carbon chain that's in a ring. So carbon likes to attach to itself. So when we start drawing molecules, if you get into like an introductory science class, if you have carbons, link them up first, at least 1 bond to each, and then you can kind of figure out where the triple bonds, double bonds are going to be when you put in all the oxygens and hydrogens. So here I can see I've got a triple bond, these have single bonds. This here is showing that I have a triple bond between the 2 right there. I have a carbon skeleton, so backbones are going to be your organic molecules, and they can be different shapes. So here I have a linear, which is the straight line. I have this one here, which is branched, which means I have carbons going off. I have ones that are double bonded. I have ones that can be in rings. And then these are super long chains. So this here is what would be, we'd call a hydrocarbon tail. This here is all hydrogens and carbons, very non-polar. We can talk about that later. So your functional groups, there's 4 main ones we're going to talk about for Intro to Biology. They're going to be your hydroxyl, carboxyl, your phosphate, and your amino group. These are the 4 big ones we kind of use a lot in Intro to Biology. If you're in AP Biology, there's 7, and I go more into depth with those in my AP Biology video. Here I have hydroxyl. Hydroxyl is considered to be a polar functional group. So a functional group is something that attaches to a carbon backbone. Here I see an R. This R is kind of representing where a carbon would be, or a carbon molecule that's over here off to the side. And then off that I would have a hydroxyl. A hydroxyl is an oxygen and a hydrogen together. So here I have ethane. I can see I have no OHs. It's just a hydrocarbon. I've just got carbons and I have hydrogens. This makes ethane very nonpolar, which means it does not react well with water. Water is not attracted to it. We call this hydrophobic. Hydrophobic means it's afraid of water. So we call it nonpolar, won't dissolve in water. But what's interesting is if I take the same thing and I remove this hydrogen and I bring in a hydroxyl group and I add this hydroxyl group to the end, I have changed the ending of it. I have an OL, and that makes it into what we call an alcohol. Ethanol is a type of alcohol. So that OH changes the property of that molecule, and now it's called polar. This will now dissolve in water. This one wouldn't, and now this one would. And so now the question is why? Well, what's changed? The oxygen. Remember, oxygen, super electronegative, very greedy for electrons. It wants all those electrons. So now I'm going to have oxygen. It's going to be pulling in some hydrogens. That hydrogen is now going to have a positive charge because this oxygen is going to have pulled the electron. That one electron that's on hydrogen is going to get pulled off, and it's going to be hanging around oxygen. This hydrogen is now basically just a proton, and it's going to have a positive charge. So how does that attract water? That positive charge is going to bring in water molecules. And remember, water is very electronegative because of this charge of oxygen. So remember, we call it polar. My poles are different. I'm very negative on this side. I'm very positive on this side. This electron, or this oxygen, has all the electrons it can hold. It has a full shell of 8. But remember, it's not happy. It still wants more. So it's trying to pull this hydrogen off, but it can't. So it's attracted to it. And remember what we call those types of bonds? We call those a hydrogen bond. Electrons don't get passed back and forth, but it's a magnetic pull to that hydrogen. So this molecule will attract water molecules to it, which will make it dissolve in water. Carboxyl, we consider this to be acidic. So remember, my R group, I have a molecule over here, carbon backbone. It's going to have some type of carbon function over here, and this is going to be on the end somewhere of that molecule. So this carboxyl group is this whole section right there. Notice I have a hydroxyl. I have a hydroxyl group here, but this combined with this hydroxyl makes it a carboxyl. This is my molecule. This here, this part here would be my R group. This is this part right here. And then this part here is my carboxyl group. My hydroxyl, and this is a carbonyl group. We'll have this group together. So this makes acetic acid. So that part there is considered acidic. So when we talk about acids, if I have a pH video, you guys can watch that too. But basically what an acid is are a bunch of hydrogen protons free floating in a solution. It's lost its electrons. The electrons have been pulled in by oxygens or other electronegative molecules, and it's popping off these hydrogen protons. So all I have are hydrogen protons floating around the solution. The more hydrogen protons I have, the more acidic. The less hydrogen protons I have, the more basic it could be. So here I have my molecule of hydrogen. I have one hydrogen molecule and one electron for hydrogen. I have oxygen. Oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. It's in a group of 6. This oxygen wants more. Remember, it's super greedy for electrons. It's going to try to pull this electron off. I'm going to bring in another hydrogen molecule and it's going to try to do the same thing. So oxygen is going to pull those electrons. Now oxygen's happy. It has a full ring of 8. It has filled this octet rule. And these hydrogen protons are now going to get popped off. And these hydrogen protons are now going to free float in the solution. But see, the electrons stayed. This oxygen is now very electronegative. It's going to have more electrons than protons, so I'm going to have a negative charge. These hydrogen protons are now what's going to cause the acidity to happen inside my solution. So what we call ionize, it's going to ionize to release electrons. An ion is a change in electrons. This oxygen changed electrons, and we have ionized to release hydrogen protons. So ionized, I can show that by showing a negative here. This is showing that I had a hydrogen here and now it's gone and I've left behind the electron. If it's non-ionized, I'm going to show that that hydrogen is here and therefore I do not have an acidic solution per se because my hydrogens are still attached to the molecule. I can show it this way. Dash COO with a minus is ionized. That's showing my hydrogen is gone. And then here I show that my hydrogen is there. We talk about phosphates. Phosphates are going to have a negative charge. They're polar and they're also considered acidic. So if they're considered acidic, what do you think is going to happen? My hydrogens are going to probably be popped off. Polar, I'm probably going to have some type of oxygen electronegative molecule there that's going to allow hydrogen bonds to form with water. This is going to allow me to dissolve. So seeing these, you can kind of start thinking of what you're probably going to see. If I have a negative charge, this is probably telling me that I have electrons that are getting pulled in that are going to have more negative charge than a positive charge. So let's look at this. My R group, this is going to be attached to a carbon backbone, and then this will be kind of like off to the side of that carbon. So here's an example. This part here is my R group. Okay, so all of this right here would be an R group. These R groups can change, but this part here is my phosphate group. I have my 4 oxygens, 1, 2, 3, 4. I have my phosphate, and then here, see, I have 2 minuses. So what was here before these minuses? Those hydrogens were. So this is telling me that this has ionized. I am now an acidic. I have hydrogen protons that are floating around in this solution. They've been popped off. And so this is one reason that makes it acidic. So that is my phosphate group. I also have a negative charge because of the negative electrons that are there. This is really important when we start talking about a lot of processes that happen in our system. ATP, adenosine triphosphate. I have 3 of these phosphate groups on the end of an ATP. And the removal of the ATP, of this phosphate group, the addition to this phosphate group, that can cause energy to be released or gained. I'm going to see these in DNA, RNA. We're going to talk about phosphorylate, which means to bring a phosphate in. Dephosphorylate, which means to get rid of a phosphate. This is big in these areas right here. So we will come back to this. And this is also going to be why DNA has a specific charge and ATP, and this is big. So we need to make sure we understand the phosphates. If I see them ionized, I'm going to see it written out like this. Again, I'm 2 negative because I have just lost my 2 hydrogen protons, and then I have 3 oxygens that are going to be here within this group. This oxygen is showing it's attached to a carbon, so I have a carbon group, oxygen, phosphate, and then these 2 oxygens are attached to that. But this oxygen is attached to a phosphate and a carbon. Okay, the last one we're going to talk about is your amino group. These are charged and they're basic. So if an acid is getting rid of hydrogen protons, basic is going to be I'm making hydroxyls, I'm making OHs. So it's pulling in hydrogens from a solution. So here I have the amino acid. This is my R group, so this is going to be attached to a carbon backbone group. I have a nitrogen and I have 2 hydrogens. So here's my R group, and then here's my N and my 2 H's. What happens is this nitrogen is pretty electronegative, which means, again, it's greedy for electrons, and it wants to pull in more electrons. All right, so I have these hydrogen protons, and these hydrogen protons are here. This is going to be electronegative, and it's going to pull in that hydrogen. So it's pulling these hydrogen protons out of the solution. And when it pulls these hydrogen protons out of the solution, what has happened to my acidity of that solution? It's going to increase, which means I'm going to become less acidic. I'm getting closer to 7. 7 is neutral. The lower I get on a pH scale, again, watch the pH video if you don't understand pH. The closer I get to 0, the more acidic, the more hydrogen protons are there. The closer I get to 7, the less hydrogen protons, and then above it I have more hydroxyls, the OHs, and I'm going to have a lot less hydrogen protons there. So now this hydrogen is going to get pulled in. I'm going to have a plus charge. This is going to change from a negative to a plus. I have more protons than electrons. The electron is not here because remember it's just a proton. So all I'm pulling in is just that proton. So this is going to change the charge of my group. I'm going to have more of a plus charge than a negative charge. So I will see that as NH3 when it's charged. So NH, and then I put a plus because remember I just added 1 proton. There was no electron with it. It was just the proton. If it's not charged, I'll just see it as NH2, which would just be this form right here. I just have a nitrogen with 2 hydrogens. All right, that's a real quick summary of functional groups. Just know that the ones that are polars, ones that can be acidic, we talk about amino acids later. It's an acid, but amino is base, and so it's make sure we're understanding kind of what those functional groups do. Okay? All right, I hope that was helpful. If it was, let me know. I'll talk to you guys later. Bye.